Hello, this is my autonomous quadruped, W.R.A.T.H. I want to make a quick progress check to mark where it is right now and to check later at the end of the summer to what extent I can finish it and to what extent I can perfect it. Over here I have a bunch of schematics of the inverse kinematics I have developed for this, and the most recent development is this, which is the stereolithography that I've been developing so that it can detect a distance of objects without using fancy LiDAR and just using these webcams that I got, one from my friend for $1 and the other one from my mom's computer. Besides that though, what's finished already is this. Right now, W.R.A.T.H is standing on standby and is balancing so that when I try to shift his weight, it can shift back against me and it can maintain balance. So, the whole robot is powered by these 25 kilogram per centimeter torque high wonder servos, which take from this 15 cell nickel metal hydrate 15 cell battery pack. So these individually draw about 6 or 7 volts, and in terms of amperage, this whole robot needs at least 5 amperes to power all 12 servos that are throughout these joints. These joints here, I have the gear powering a 1 to 3 gear set so that the 270 degrees of motion here are converted into 90 degrees range in the paw. I have on one side teeth, and on the other side it's alternating teeth so that the load that is exerted is always at maximal performance. And in between these two staggered teeth sets, I have this rib so that when the joint is under a lot of stress and it's shifting, it never loses contact, which is a huge problem my previous design had. Now, each leg is pretty much a mirrored or it's exactly the same for each leg, just mirrored if it's on the other side because of these unique roll joints. And the whole robot is put together with PVC pipes. The main brain for this is the Raspberry Pi 4, which is the most advanced thing I could get my hands on, and I can show it to you in closer detail by removing this battery. So in here, I made a custom hat for my Raspberry Pi so that I could plug in all of my appliances hassle-free. The first one, which I use to communicate with this wirelessly, is the AT09 Bluetooth module. And since I use iOS and I'm an iOS developer, I need this one instead of the HM10 or HC05, which are exclusively for Android. This is a switch I just filched from my school with permission. And this is controlling all the servos. This is a PCA 9685 servo driver. I can pop the switch off the 3D printed clip I made, and I can show you in a bit closer detail what it looks like. So I took off this support brace, and in here you can see the gangle of wires where the PCA 9685 is, which can take up to 16 servos, and I'm using 12, as I said, for the body, and I'm going to be using, I think, at least 2, maximum 4 more, which would be for the stereolithography, and I have wires dangling out here so that the eyes can shift and be able to track an object. Now at the belly, as close as I possibly could to the center of mass, I have this MPU 6050 balance module. I'm going to lift the robot. It's going to start fighting me because it wants to balance, but it's going to need to stay like this for a little. You can see over here a little I2C module. I2C standing for Inter-Integrated Circuit, which is pretty much just a separate module that you can connect with a SCL clock and SDA data wires, and they just send zeros and ones really, really quickly so that they can transfer data to each other. And I'm using, which is not recommended, but I'm using Raspberry Pi's bus 1 and bus 0 for the I2C modules so that it's able to communicate with both. And as I said, this was my power supply, which is 6 volts and at least 5 amperes, but it can draw slightly more. In here, I have this huge brick, which is 5 volts and about the same amount of amperage, which I use to power the Raspberry Pi separately. I don't know the model number or any further information. I purchased this, well, this one I made, and the reason why I have 2 separate battery packs is because, especially when I would start pressing on the robot, I would start viciously shaking it, it would need so much amperage that it would draw everything from here, and if this was connected, it would just boot loop. It would lose all power and restart. So to prevent this, I have 2 completely separate power supplies so that I never have to face this issue. I can put the battery pack back, and I think for the progress that I already have so far, that is all. If you would like to see the robot actually walking, balancing, and doing other things, please check out the other videos on my channel that also documents the progress. And just quick disclaimer, none of this is sponsored for the individual products. I would just like to give high accuracy if anyone wants to replicate this open source project. And if you look at this description below this video, you'll see a couple affiliate links that I have to products of this on Amazon. Because of tight money, I have a predilection to have the cheapest and most reliable stuff, so I'd highly recommend to purchase it. And they are affiliate links, so you'll be paying no extra price, but as soon as you purchase it, I'll get a small share of what Amazon is supposed to take for itself, and it can help fund this project. So thank you very much. Have a lovely day.